Earth's climate is always changing, constantly in a state of flux. It's like a giant seesaw going up and down, never staying still for long. Sometimes it's warmer, sometimes it's cooler, reflecting the dynamic nature of our planet. These changes can be natural, driven by forces beyond our control. They happen over long periods, often taking centuries or even millennia. But sometimes, these changes happen more quickly, within a human lifetime. They can be more dramatic, causing significant impacts on our environment. This is where La Niña and El Niño come in, playing a crucial role in our climate system. La Niña and El Niño are climate patterns that originate in the Pacific Ocean. They start in the Pacific Ocean, influencing weather far beyond their origin. They affect weather all over the world, from droughts to floods. These patterns are part of a cycle called ENSO, which stands for El Niño Southern Oscillation. ENSO stands for El Niño Southern Oscillation, a key driver of global climate variability. It's a fancy name for a natural climate phenomenon that has far-reaching effects. ENSO has three phases: El Niño, La Niña, and neutral, each with distinct characteristics. The neutral phase is like the baseline, a period of relative stability. It's what happens when neither El Niño nor La Niña is active, maintaining a balance. These phases influence the distribution of warm water in the Pacific Ocean, altering weather patterns. This, in turn, affects weather patterns globally, impacting ecosystems and human activities. Understanding these phases is crucial for predicting and preparing for climate impacts. It helps us prepare for the impacts on our planet, from extreme weather events to shifts in ocean currents. From extreme weather events to shifts in ocean currents, ENSO plays a significant role in shaping our world. Let's delve deeper into these fascinating climate phenomena and understand their importance. The Pacific Ocean is vast. It plays a crucial role in our planet's climate system. At the heart of La Niña and El Niño is a phenomenon called the Walker circulation. This circulation is like a giant conveyor belt of air. It moves across the tropical Pacific. Normally, trade winds blow from east to west across the Pacific. These winds push warm surface water towards Indonesia and Australia. This creates cooler water upwelling off the coast of South America. This is the normal state of the Pacific Ocean. However, during La Niña and El Niño, this circulation changes. This change disrupts the normal patterns of ocean temperatures. It leads to widespread impacts on weather patterns. Let's explore how these two phases differ in their characteristics. La Niña is Spanish for little girl. It's the cool phase of ENSO. During La Niña, the trade winds blowing across the Pacific Ocean become stronger. They push even more warm water towards the west. This creates a larger temperature difference across the Pacific. The eastern Pacific, near South America, becomes colder than usual. This change in ocean temperature affects the atmosphere above it. It leads to changes in weather patterns across the globe. La Niña events typically last 9 to 12 months. Sometimes they can persist for 2 years or more. These events are a natural part of the climate system. Understanding their characteristics is vital for predicting their global impacts. El Niño, meaning the Christ child in Spanish, is the warm phase of ENSO. Unlike La Niña, El Niño weakens the trade winds. This allows warm water that's normally confined to the western Pacific to spread eastward. As a result, the central and eastern Pacific Ocean become warmer than usual. This warming affects the atmosphere above it. It disrupts the normal patterns of rainfall and atmospheric circulation. This leads to changes in weather patterns across the globe. El Niño events typically occur every 2 to 7 years. They can last for 9 to 12 months. Understanding the characteristics of El Niño is crucial for predicting its global impacts. Section 5. Predicting the weather's mood swings. Scientists use various methods to predict and monitor La Niña and El Niño. These methods help us understand when these events might occur and how strong they might be. One of the key tools is monitoring ocean temperatures. Satellites and buoys deployed across the Pacific Ocean constantly measure the sea surface temperature. These measurements help scientists detect any unusual warming or cooling. This provides early indications of a developing El Niño or La Niña event. Another important tool is monitoring the atmosphere. Scientists observe changes in atmospheric pressure, wind patterns, and cloud cover. These factors provide further clues about the development and intensity of these climate patterns. Section 6. La Niña's global reach. La Niña's impacts are felt worldwide, influencing weather patterns in various regions. In the eastern Pacific, it brings cooler and wetter conditions. This can lead to increased rainfall and flooding in some areas. Conversely, La Niña often causes drier conditions in the western Pacific. This can lead to drought in countries like Indonesia and Australia. These changes in rainfall patterns can have significant impacts on agriculture and water resources. Moreover, La Niña can affect the Atlantic hurricane season. It tends to increase hurricane activity. This is due to reduced wind shear, which allows hurricanes to develop and strengthen more easily. Section 7. El Niño's wide-ranging effects. Just like La Niña, El Niño also has far-reaching impacts on weather patterns globally. One of the most significant effects is the increased rainfall along the western coast of South America. This can lead to flooding and landslides in countries like Peru and Ecuador. On the other hand, El Niño typically brings drier conditions to Indonesia and Australia. This can result in drought and increased risk of wildfires. These changes in rainfall patterns have significant impacts on agriculture, water resources, and ecosystems. Furthermore, El Niño can affect the jet streams, influencing winter weather patterns in North America. It often leads to milder winters in the northern US and Canada. Section 8. Farming and food. Feeling the heat and the chill. Agriculture, being heavily reliant on weather patterns, is particularly vulnerable to the impacts of La Niña and El Niño. These climate phenomena are known to cause significant disruptions in farming activities. These climate phenomena can disrupt growing seasons, affect crop yields, and threaten global food security. The unpredictability of weather patterns makes it challenging for farmers to plan and manage their crops effectively. During La Niña, the increased rainfall in some regions can benefit crops, leading to lush and bountiful harvests. However, it can also lead to flooding, damaging crops, and reducing yields. Excessive water can drown plants and wash away essential nutrients from the soil. Conversely, the drier conditions associated with La Niña in other regions can lead to drought, affecting crop growth and increasing the risk of crop failure. Water scarcity becomes a critical issue, stressing both plants and farmers. El Niño also has significant impacts on agriculture. Its effects are often felt globally, altering weather patterns across continents. The warmer and drier conditions associated with El Niño can lead to drought in many agricultural regions, affecting crop yields and increasing food prices. The economic impact can be severe, influencing both local and global markets. These impacts highlight the need for climate-resilient agriculture and adaptation strategies to mitigate the effects on food security. Farmers are increasingly turning to innovative techniques to cope with these challenges, ensuring sustainable food production for the future. Section 9. Life in the ocean. Riding the temperature waves. The impacts of La Niña and El Niño extend beyond land, significantly affecting marine life and ecosystems. These climate patterns are crucial in shaping the underwater world. These climate phenomena influence ocean temperatures, currents, and nutrient availability, with cascading effects on marine organisms. The changes can be both beneficial and detrimental, depending on the species and region. During La Niña, the stronger trade winds enhance upwelling off the coast of South America, bringing significant changes to the marine environment. Upwelling brings cold, nutrient-rich water from the depths to the surface, supporting a thriving ecosystem. This process is vital for the productivity of marine life. However, during El Niño, the weakened trade winds reduce upwelling, leading to warmer surface waters and fewer nutrients. This shift can have far-reaching consequences. This can disrupt the marine food web, affecting fish populations and other marine organisms. The lack of nutrients can lead to a decline in fish stocks and other marine life. For example, El Niño events are known to cause coral bleaching, a severe stress response in corals. This phenomenon occurs when corals expel the algae living in their tissues, which are essential for their survival. As a result, corals turn white and become more susceptible to disease and death, threatening the entire reef ecosystem. Section 10. Adapting to a changing climate. As we continue to experience the impacts of La Niña and El Niño, it becomes increasingly crucial to adapt to these changing climate patterns. Adaptation strategies are essential to minimize the negative consequences and build resilience to these events. One crucial aspect of adaptation is improving early warning systems. By accurately predicting and monitoring these climate phenomena, we can provide timely information to vulnerable communities, allowing them to prepare for potential impacts such as droughts, floods, and heat waves. Another important strategy is implementing climate-smart agriculture practices. This includes developing drought-resistant crops, improving water management techniques, and adopting sustainable farming practices that enhance soil health and reduce water usage. Section 11. Climate's unpredictable future. La Niña and El Niño are powerful reminders of the interconnectedness of Earth's climate system. These climate phenomena, with their far-reaching impacts on weather patterns, agriculture, and marine life, highlight the importance of understanding and adapting to a changing climate. As our planet continues to warm due to climate change, scientists predict that the frequency and intensity of extreme weather events, including those influenced by La Niña and El Niño, are likely to increase. This underscores the urgency of reducing greenhouse gas emissions and mitigating the impacts of climate change. By understanding the complexities of these climate phenomena, investing in research and monitoring, and implementing effective adaptation strategies, we can better prepare for the challenges of a changing climate and build a more sustainable future for all.